Hello students, this video lecture will cover section 11.3, surface area of pyramids and cones. By the end of this lesson you should be able to find the surface area of both a pyramid and a cone. So just like last time, let's start with some vocabulary. A pyramid is a polyhedron in which one face, called the base, can be any polygon, and the other faces, the lateral faces, are triangles. They meet at a common vertex called the vertex of the pyramid. A pyramid is named by the shape of its base. The altitude of a pyramid is the perpendicular segment from the vertex to the plane containing the base. The length of the altitude is called the height of the pyramid. A regular pyramid is a pyramid whose base is a regular polygon and whose lateral faces are congruent isosceles triangles. The slant height is the length of the altitude of a lateral face of the pyramid. In our class, we can assume that all pyramids are regular pyramids unless stated or pictured otherwise. So this is a visual representation of the vocabulary that we just went over. The lateral area of a pyramid is the sum of the lateral areas of the congruent lateral faces. To find the surface area of a pyramid, we add the area of its base to its lateral area. So here, Theorem 11-3 gives us the formulas for the lateral area and surface area of a pyramid. The lateral area of a regular pyramid is half the product of the perimeter and the slant height of the pyramid. The surface area, we take the lateral area and add that to the area of the base. So let's go ahead and find the surface area of a pyramid. A square pyramid has base edges of 5 meters and a slant height of 3 meters, and we're asked to find the surface area. Well, the first thing that we want to do is draw a picture so we can get a good visual representation of what we're looking at. So our square pyramid here has base edges of 5, so all of these edges are 5, and the slant height is 3 meters. So we connect the vertex to the midpoint of one of the bases. So this is our slant height. This is a 90-degree angle along that face. And this length right here is 3 meters. All of these are 5 meters. So as we recall from the previous slide, we have the lateral area is 1/2 the perimeter times the slant height. And the surface area is the lateral area plus the area of the single base. So lateral area is 1/2 the perimeter of the base. There are 4 sides, and each side has a length of 5. And the slant height here is 3. So 4 times 5 is 20. Half of 20 is 10. Times 3 is 30. So the lateral area is 30 square meters. So the surface area then is going to be 30 plus the area of the base. Since the base is a square pyramid, we know that the area of the base is 5 squared. So we have 30 plus 5 times 5, which is 25. And so we find that the surface area of this pyramid is 55 square meters. Question number 2 asks us to find the lateral area of a given pyramid. It says, what is the lateral area of the hexagonal pyramid below? And we want to round to the nearest square foot. Well, as we recall, the formula for lateral area is 1/2 the perimeter of the base times the slant height. So here we have 36 as a base edge. We know that the perimeter, this is a hexagon, so it has 6 sides. Each side has a length of 36. And 6 times 36 is 216. So now we need the slant height. So we have a problem here. The slant height is actually not even pictured. So for the slant height, we need the length of this dotted blue line. So let's go ahead and draw another picture. So in this case, we have a height of 42 The bottom of this is 18 times the square root of 3. It is conveniently a right triangle, so we can use the Pythagorean theorem. So to find the length of the hypotenuse, we have 42 squared plus 18 square root of 3 quantity squared has to equal the length of this blue line, and I'm going to call that L squared. 42 times 42 is 1,764. 18 times the square root of 3 squared is 972. And so the sum of these two is 2,736. And so this equals L squared. So to find the length of the slant height, we take the square root of both sides, and the square root of both sides is about 52.3. Keeping the actual value for L on my calculator, I'm going to go ahead and multiply that by the perimeter, which was 216, and I get that P times L is around 11,298. Divide that by 2 and I find that the lateral area to the nearest square foot is 5,649 square feet. So like a pyramid, a cone is a solid that has one base and a vertex that is not in the same plane as the base. However, the base of a cone is a circle. In a right cone, the altitude is a perpendicular segment from the vertex to the center of the base. The height is the length of the altitude. The slant height is the distance from the vertex to a point on the edge of the base. In this class, all cones are right cones unless stated or pictured otherwise. The lateral area is half the circumference of the base times the slant height. The formulas for lateral area and surface area of a cone are similar to those for a pyramid. So Theorem 11-4 gives us the formulas for both lateral and surface areas of a cone. The lateral area is pi times the radius times the slant height. The surface area is going to be the lateral area plus the area of the base. Your textbook doesn't go so far as to write this, but this is pi times the radius times the slant height plus pi times the radius squared. So let's go ahead and find the surface area of a cone. So here we have a picture of a cone. It has a radius of 16 meters at the base and a slant height of 28 meters. And we want the surface area in terms of pi. From the previous slide, we know that surface area can be found by multiplying pi times the radius times the slant height plus the area of the base, or pi r squared. So plugging numbers into this formula, we have pi times the radius, 16, times the slant height of 28, plus pi times the radius, 16 squared. 16 times 28 is 448, so this equals 448 pi, plus 16 squared is 256 pi. So combining the like terms, we get 704 pi meters squared. So here we're asked, what is the lateral area of a traffic cone with a radius of 10 and a height of 28? We're asked to round to the nearest whole number. Now, as nice as this picture of the traffic cone is, oftentimes fancy pictures aren't really worth anything. So here we have a cone that'll be a little bit more useful. The radius of this cone is 10 inches, and the height is 28 inches. So if we connect the vertex of the cone perpendicularly to the base, we get that this is 28 inches. Now, remembering back to formula for lateral area, we know that the lateral area is pi times the radius times the slant height. So let's go ahead and plug in the numbers that we know. We have pi times the radius, which we're told is 10, times the slant height. See, another situation where we have to actually calculate the slant height. So using the Pythagorean theorem again, we have that the slant height is 28 squared plus 10 squared. 28 squared is 784. Plus 10 squared, which is 100, is going to equal L squared. So L squared equals 884. And so L equals the square root of 884. Now normally I would simplify the square root of 884, but since I'm going to round my final answer anyways, I might as well just keep it. So I'm going to multiply the square root of 884 times 10, and then I'm going to multiply that result by pi. And I find here that rounded to the nearest whole number, the lateral area of this cone would be 934 square inches. So that concludes this video lecture on section 11.3. Hopefully you understand now how to find the surface area of both a pyramid and a cone. Thank you for your attention, and I'll see you soon.